So our last topic in this section is optimization. It is maximums and minimums, which we've been doing, except a word problem. That's the only difference, okay? You've been doing maximums and minimums. You did them on the quiz you just took. It's just going to be a word problem, okay? So step one, you're going to get an equation for what is being optimized. So if they say to maximize area, you need an equation for area. If they say to minimize cost, you need an equation for cost. Optimized means max or min. So whatever they say to maximize or minimize, you need an equation for that thing. With me so far? Okay. Equation for what is being optimized in terms of one variable. So if there is more than one variable, you have to do algebra to get rid of the other one through doing a substitution. Do you remember back in related rates? I know you're like, no, we've repressed that entirely, Miss Cole. Do you remember the volume of the cone one? Volume equals 1/3 pi r squared h. Do you remember you had r equals 1/3 h and you had to substitute it in and do a big bunch of algebra? It's like that. I'm seeing heads nodding. You know what I'm talking about, right? So you sometimes have to substitute to get it in terms of one variable. And then how do you get your maximums and minimums? You did it on your quiz. It's what? What is that? Well, what goes on the table for that? Do you say that louder? Critical points. Critical points are what gives you your maximum and minimum. How do you get critical points? Derivative equals 0. Okay, so you get your equation. If it's not already in terms of one variable, you got to do some algebra to substitute. Critical points are derivative equals 0. All right, I'm going to do a bunch of examples. All right, two numbers have a sum of 20. We're going to find the maximum product. Let me just do the problems, don't worry. Okay. So two numbers have a sum of 20. What is their maximum product? So you need an equation for a product. It says to maximize the product. I'm going to use P for product. You can use any letter of the alphabet you want. There's 26 to choose from. Okay, but I'm going to use P for product. You want to pick letters that make sense in the problem. All right, so what does product mean? Multiplying. I'm going to use X and Y for my two numbers. Sometimes people use A and B. It doesn't matter. Again, it's like personal preference, but something times something else. Now, what's the problem with that? X and Y, you have two variables. So you got to go back to the problem and find another piece of information. What else were we told? 20 is the sum. What does sum mean? Plus, adding, addition. Good. So X plus Y is 20, and we're going to isolate one of those. It will not make a difference, and most of the time it doesn't. Do you want to isolate X or isolate Y? Okay, it doesn't matter. So we'll subtract over the X. And again, this is not calculus. This is like 90% algebra. The only step that's calculus is when you do a derivative, right? That is going to get substituted in for Y. So your product is going to be X times all of that. And then what would you need to do with that? We're going to distribute. So if you distribute the X, you're going to get 20X minus X squared. That's all the algebra. Now it's critical points. So it's derivative equals 0. So P prime is what? What's our derivative of that thing that we got? Yep, 20 minus 2X. And we're going to set that equal to 0. Critical points are derivative equals 0. And then more algebra. That's the only step that's calculus, is doing the derivative equals 0. Now what? Yeah, minus 20. Good, and we get X equals 10. Yay, we're not done. If X is 10, what is Y? Also 10. That should not surprise you that the most optimal numbers are when they're the same. It's kind of like the best rectangle is a square. You know what I'm saying? Okay. And so what's our maximum product? If you multiply those together, 100. So that being said, unless something goofy happens, and if something weird happens, you're going to be like, hey, that was weird. The best rectangle will be a square. So let's try another one and we'll see if you can get the answer without having to do any of that. And I am telling you to be lazy. I am. I want you to do the least amount of work possible to get the correct answer, okay? Because the thing is timed. Two numbers have a sum of 10. What's the maximum product? Two numbers have a sum of 40. What would the two numbers be? 20 and 20. What's the maximum product? Good. You guys got it? You can do it without any work. All right, let's try another one. I changed the question a little bit, but it's the same idea. The best rectangle, the most optimal I shouldn't say best, not like some rectangles are better than others, but like the most optimal rectangle is going to be a square. But this time I gave you the perimeter. So what's a perimeter? Let's just start there. Yeah, like adding up all the sides. So if it's a square and your perimeter is 48 feet, what's each side going to be? 12. Now, if you don't want to draw this, you don't have to. I'm just doing it for the sake of if anyone like wasn't here and they're just watching the video to show you what we're talking about. It would be 12 by 12. And so what's the area? Oh, good. I was going to ask that as well. Why is it squared feet? Area. You guys make my life easy. That's awesome. Now, and we did this in pre-calc. I gave you the perimeter, but I took away one of the sides. Do you remember the fence is going to be up against a pond or something? So one side is taken care of. That throws this off and it won't be a square anymore. Do you see what I'm saying? Or do you need us to, like, let's try that. Let's call this 2B. I'm going off script here. We'll call this 2B. Say the perimeter is 48 feet, like you have 48 feet of fencing, but you're making your fence up against a pond or a structure that's already there. Do you get what I'm saying? So you only need 3 of the sides. The 4th side is taken care of. All right, so we're going to call this X and this Y. Area is still X times Y. It's length times width, but what's the problem with that? We have 2 variables. We have an X and a Y. You have to substitute one of them out. But what did we say? How much fencing did I say we had? I'm just using the same information. 48. So if you add these up, you get 48. That would be X plus 2Y gives you 48. Now, it doesn't technically matter which variable you isolate, but there is one that's easier there. X is easier. Do you see what I'm saying? All right. So you're going to subtract over the 2Y and take it, that and substitute it in for X. Do you have any flashbacks to this? Do you remember doing this in pre-calc? We do this. The only difference is we just don't take a derivative. I teach you a different way to do it because you don't know what a derivative is. It was in the quadratics unit. Do you remember negative b over 2a? Quadratic formula? Anyway, it was in that unit. We did it. You can look back at the videos. I have proof. All right, so you're going to take out X, replace it with all of that. And then what would you need to do with that Y that's out front there? Distribute. So you're going to have 48Y minus 2Y squared. And then what's the only step that's calculus? Derivative. That's how you get your critical points. Believe it or not, that's the step that people forget to do. They'll just take this and set it equal to 0. And it's like, you did not do any calculus at all. Make sure you take a derivative. All right, what would your derivative be? Yep, minus 4y, good, equals 0. And then just keep going. You want to solve that. So subtract the 48. And y would be 12. But x is not 12. It's not a perfect square because you took out one of the sides, like you threw it off by a little bit. If y is 12, so both of these are 12, if we're looking at our picture, you have 48 feet of fencing available. What's left for x? 24. And so your total area would be whatever 12 times 24 is. I'm going to be real honest. I don't know that off the top of my head. Does anyone know 12 times 24? I'm typing it in. Let's see. 288 square feet. Why'd we get more square footage for that one than we did for this one? You already had one of the sides taken care. Good, common sense. We've got it. All right. I'm gonna need a calculator for this one too. And I'm actually going to act this one out for you. This is a very famous calculus problem, the box problem. Every person taking AP calculus in the entire United States is doing this problem. Okay. A box is made from an 8.5 by 11 inch of paper. We're going to cut out some of the corners. We want to find the maximum volume. I'm going to show you what this looks like. I'm going to try to get it on the video as well so that anybody watching it can see it. What we do is take an 8.5 by 11 piece of paper. Unfortunately, this one has holes in it. But what you're going to do is cut squares of equal sizes out of the corners. And hold on, I'll put it under there so you can all see it. You see what I'm doing here? I used to, back in the day, make everyone make a box. I would be like, it's arts and crafts time, everybody. We're not going to have time for that, though. All right, you see what I did there? Looks like this. Okay, and then what you do is you fold the sides of it up and it becomes three-dimensional. See what I'm saying there? You have a box that you can put things in. Cool, heads nodding, you got it. We took it from two-dimensional to three-dimensional. So what we're gonna do is label this distance as X. And they would all be X, like it's all gonna be the same, all right? So when I draw that on my paper, unfortunately, it's going to be two-dimensional because I'm drawing it on a piece of paper here. But this is your 8.5 by 11 piece of paper. You're going to cut out a square from each corner so you can fold up the sides, make it three-dimensional. And the length of each of those is going to be X. So they're all the same. Now, what is the thing we're trying to optimize? Volume. That means you need an equation for volume. So how do you do the volume of a box? Yeah, like each of the dimensions times length times width times height. All right, let's do the length first. How long was the piece of paper before we cut anything out? It was 11 inches. But look, we cut out X from this side and we cut out X from this side. Good, so this portion of it that's left is 11 minus 2X. You took out X from each side. Then we're going to do the width. How wide was the piece of paper before you cut anything out? Yeah, 8.5. But how wide is it now since you cut this out? Yeah, good. 8.5 minus 2x. So that's the length, that's the width. What's the height? Good. When you bend it up, that's the fastest I think anybody's ever gotten that. Usually I have to pull that out of everybody. Do you see how that length is x? When you fold it up, x becomes the height. That's the height of the box. Now there's good news and bad news. The good news is how many variables is that? One, it's just x. So you don't have to do any substituting. The bad news is you got to multiply all that together. Okay. But you would be allowed a calculator for this. So I've got mine here. If we need to type anything in, we can do that. All right. So 8.5 times 11. Let's see. Does anyone know that? 93.5. I just typed it in. The outsides would give you what? Yeah, minus 22x. The insides, how would that be? 17 minus 17x. So together, that would be minus 39x. Good. And then negative 2x times negative 2x, that would be plus 4x squared. All right, and then what do we still need to do? Distribute the x. All right, so 93.5x minus 39x squared plus 4x cubed. Don't forget to do the most important step, derivative. Good. Okay, what's our derivative going to be? Yeah, 93.5 minus 78x, perfect, plus, ooh, close, 12x squared. There we go. Equals 0. Now here's where you would need a calculator because that won't factor. I'm going to just type for you. Can you all watch? We're going to go to y equals, clear out the stuff that's in there. And I'm going to type in that equation. 93.5 minus 78x plus 12x squared. I'm gonna do zoom. Do you remember what standard is? What number is standard? Zoom 6. We'll put it to standard. Zoom back in. And we're looking for critical points. How many critical points do you see? Good, perfect. There's one right there and one right there. Which one is it? What did we want to do to volume? Maximize. That is a change from what to what? Good. Which one of these has a change from above to below? The first one or the second one? First one. If you accidentally pick the second one, when you plug it back in, you will get a negative volume and you will go, oh, whoops. What that means is you would have cut out so much from the corners of your paper that there would be no paper left. Okay, so it's going to be this one. How do I get my calculator to tell me that number? Trace? Which thing? 0? Now it looks like it's in between 1 and 2. So left bound, I'm going to do 1 enter. Right bound, I'm going to do 2 enter. Guess. Well, it's got to be between 1 and 2. So 1.5. And it gives you the number. Go ahead and write that down. X equals 1.585418. The reason you need all the decimals is because why? Why would you need them all? It's not your answer. You're not done yet. You still need to reuse that. 1.585418. What are we looking for? Since that's not the final answer, what do I need to do with that? You plug it back into the original one. Okay, so 11 minus 2 times 1.585418. And then 8.5 minus 2 times all of that. And then times that number. Because at the end, it was just X. You see what I'm saying? I did 11 minus 2. Okay, thank you for heads eye. It's just a bunch of button pushing. All right, so there's the final answer, 66.148. You can truncate that now that we're done, but what are your units? Inches cubed.